How do you find the orthocenter when it comes to an obtuse triangle? Notice that when we're talking about an obtuse triangle, the orthocenter will be outside. Okay? Notice that when you have a right triangle, this is an obtuse triangle, and the way to know that is to realize that this is a longer side than this one. That's one way to tell using your eyes. But also another way to tell is to see that the slope here is 1 of this line. Okay, and the slope here is not -1, but it's greater than that, right? The slope is going to be precisely 2 down and 5 to the right, right? So -2, 5. Change in y divided by the change in x, right? -2, 5 is definitely greater than -1, as it should have been if this were two perpendicular lines, right? So this is not a right triangle. This is an angle greater than 90 degrees, right? So this is an obtuse. So definitely, whenever there's a right triangle, the orthocenter would be precisely this vertex on the top. And we know when it comes to orthocenters, uh, we draw altitudes from each vertex so that it is going to be perpendicular to the opposite side, right? In this case, we definitely will draw an altitude from this side to this vertex, but since this is not a right triangle, this vertex is not going to be the orthocenter, it's going to be outside, right? It's definitely going to be on this vertical line. So first we're going to draw this line here because we know it's going to fall somewhere. The orthocenter will be on this line. Now we know that the orthocenter is the point of concurrency for 3 such altitudes, right? Because we know from orthocenter properties that when you have 3 vertices and you draw an altitude from each vertex to the opposite side so that it's perpendicular to it, there will be a point at which 3 such altitudes meet. In this case, you realize, how can I draw from this vertex an altitude that is perpendicular, right? Because this is already not a right angle, right? So that means these two these two sides are not perpendicular to each other. So even, the further you go, it's not going to be perpendicular either, right? It's going to get more and more obtuse, until you basically get to 180 degrees, right? So the way to do this is to realize that you can extend each side. You can extend this side because simply if you find one such altitude successfully, you will not have to find a third one, because you know that all 3 altitudes meet at one concurrency point, which is the orthocenter somewhere on this line. And you don't need to find a third one, because if all 3 of them meet, then it's sufficient to realize that 2 of them meet at the same point too, right? So you don't have to find the third one. So let's find the second one. To find the second one, we're going to extend this side, because we know that from this vertex there will be an altitude drawn in such a way that it will be perpendicular to this side if we extend it, if we extend this opposite side, right? Because right now, as we just said, there's no way to draw an altitude from this vertex to the side such that it is perpendicular, right? So we have to extend this side. But how do we extend it successfully? We extend it successfully knowing how many boxes we need to count, right? So we know to get from this point to this point, we count 2 down and then 5 to the right, right? Because we realize that the slope of this line for this line segment was -2/5, right? So 2 down, 5 to the right. So logically, to go from right to left, you must count 5 to the left and 2 up, right? 1, 2, 3, 4, 5, 2 up, right? So that would be the point to which we have to extend. So let's extend that, and we get right here, right? That's how we connect it. Now, you realize that, as we talked about before, the slope of this is going to be -2/5, right? So we went 2 down and 5 to the right. So from here, if you want to make a successful perpendicular altitude to this extension here, you have to do the opposite, right? You're not going to count 5. You're not going to count 5 to the 2 down and 5 to the right. Instead, you're going to do the opposite, right? You're going to do 5 up and 2 to the right. 5 up and 2 to the right, right? That makes sure that you will have a negative reciprocal, right? Because the negative reciprocal of negative 2/5 is going to be precisely 5 over 2, and it's going to be positive, right? So 5 up and 2 to the right. So let's find the points. 1, 2, 3, 4, 5. 2 to the right. Okay? Now, don't worry about the fact that the point at which you find the perpendicular relationship here is not going to be a corner. It's not going to be a precise point, because your goal is to keep extending using the slope 5 over 2 to get to eventually a point on this first altitude that we drew, right? Because that altitude, as long as it meets this altitude, and I promise you it will be a corner, as long as you meet it there, you will be successful, right? You will have found an orthocenter precisely on this line. So let's take care of that. So 5 up, 2 to the right, and keep going. 5 up, 1, 2, 3, 4, 5, 2 to the right. Bingo! You see, we landed right on the corner. So guess what? And like I said, this is not a corner at which there's a perpendicular relationship, and that's okay, because this is not where you're trying to get at. You're trying to get at this point, the point of concurrency, and this is precisely the orthocenter. Okay, this is precisely the orthocenter, so why don't we mark it? And the coordinates of that would be, of course, -2, right? Because this is the origin, -2, and then 1, 2, 3, right? So -2, 3. You have successfully found the orthocenter coordinates. Now, keep in mind that in the same way that you've done this, you would extend this side if you were to do this with the other vertex instead of this one and treated the third line like the second line and letting go of this one, you would have arrived at the same point. And just for practice, we can do the same thing just to check, right? We can extend this. We know the slope of this is 1. So let's extend this fellow. Let's extend him. So we know the slope is 1, so we have to extend him. Let's extend him up to that point, right? So we're extending this side basically using the property that this is slope 1. Now this, the point from this vertex here that we draw must cross this line at a 90-degree angle, just like this first altitude did with the extension here of that side, right? So the extension of this side must meet the altitude that we draw from this vertex so that there's a 90 degrees. Okay, so now let's keep in mind, this will be very easy to find the reciprocal, right? Because the slope here is 1, so that means the slope from this vertex of the altitude, the third altitude that we need, is going to be -1, right? So that means it's going to be going at these corners, right? It's going to basically rise from right to left by 1. One left, 1 up, 1 left, 1 up, right? So that's pretty easy, right? We don't have to count different numbers like 5 and 2, etc., right? It's going to be 1 left, 1 up, 1 left, 1 up, right? So notice where we're going. We're precisely going, guess what? At the same location, right? At the orthocenter right there. You see? And we didn't violate the slope property. It's still -1, the slope of this, right? The negative reciprocal of this altitude, not the altitude, the extension, right? So this is the altitude, this is the extension, right? And notice that this is still 90 degrees like it should be, like in the first case, right? So I'm going to mark it so that you understand it and you don't forget it. Like this is the extension, right? So I'm going to mark it like this. Extension, this part, right? Well, I should probably mark it here. Extension, right? And this is an altitude. Right? So if you were to draw this first, you would have arrived at the same point as long as you draw the first altitude. The first altitude is obvious, right? It must make a 90 degree with the opposite side, right? Right? Because this is the vertex, right? This is the vertex, and we know that the altitude will make a 90 degree angle with the opposite side, right? So that should be obvious, right? And that's easy to understand, that's easy to draw, it's just a vertical line. And then that's easy, you choose either this one or that one, whichever you draw first, as long as you make the extension, right? This is the extension. This is the extension line. right? And the altitude is this one, of course, right? The one that makes a 90 degree with the extension line, right? So this is the altitude, right? Altitude, extension line, needed to draw that altitude. In the second case, if you were to start in this vertex after you draw the very first one, the first altitude, if you were to draw the altitude from this vertex, you would have to extend this side, right? That's why I wrote extension there. And long enough so that you have room for 90-degree angle with the altitude that you begin drawing from that vertex, right? So you go up and you notice you wind up in the same location with which is the orthocenter. Okay, so I hope that this was fun. This was a lot of fun. As you can see, this is not very hard to do. As long as you understand the concept of slope, the concept of negative reciprocals, how to use the boxes to count properly, right? You will be fine in finding the answer to this kind of problem. So thanks so much for watching. I'll see you in the next video.